This is Joe narrating a PowerPoint in science from the unit on physical science. It's lesson 5, motion and forces. This is found on page 550 in the Kaplan book. Some new vocabulary. Isaac Newton in 1687 wrote a book in which he described the laws of motion. The first law is called the law of inertia. This just says that a body at rest or an object at rest will tend to remain at rest unless acted on by a force. Or an object in motion will tend to remain in motion along a straight line unless acted upon by a force. The second law says that a force will cause a mass to accelerate. The larger the force, the larger the acceleration. This is probably the second most common equation that physics students will remember, F equals ma, along with the equation we studied in the last lesson, E equals mc squared. The third law of motion says that for every action there is an equal and opposite reaction. Another way to say this is that forces come in pairs. Your book talks about the difference between speed and velocity, talks about acceleration, which is just a change in velocity, and the last paragraph talks about momentum, which is mass times velocity. So we're very familiar with the concept of speed from driving cars. If you're driving at 40 miles an hour, 40 miles an hour is your speed. Velocity just takes the concept of speed and also applies a direction to it. So you have to specify not only the speed, the rate of change in a unit of time, but you also have to specify the direction. So velocity is just speed in a certain direction. Acceleration is the change in velocity. So you have to have a change in speed or a change in direction that will be called an acceleration. This diagram shows Newton's first law, an object described by this blue ball. With no outside forces, the object will never move. If you apply an outside force, the object will never stop, theoretically. Air and friction from the surface that the ball is rolling on will eventually stop it, but those are considered forces. So on a frictionless surface and no air surrounding it, if you push an object, it will stay in motion forever. For example, in space, if you fire a rocket on a spacecraft, that spacecraft will continue off moving forever. Newton's second law can be described in two ways. Here you have the same object receiving different amounts of force. On the upper diagram, a large force will cause this object to accelerate more than it would than if you apply a small force to the object. So basically, a big force causes a big movement and a small force causes a small movement if you have the same sized object. Another way to look at this is if the forces are the same force will cause a small object to move faster and further than the same force will cause a large object to move. So same force, small mass, larger acceleration. This goes back to F equals ma. Newton's third law states that forces come in pairs, so whenever you see a force in the world, there will be an action and a reaction. For example, this is a cartoon of a soldier firing a gun. The force of the explosion in the barrel of the gun caused the bullet to move off to the left, but it also caused the gun to move off to the right. And this is why you should shoot a rifle with it securely contacting your shoulder, because otherwise the gun will move very quickly after the bullet leaves and smash into your shoulder. We see Newton's third law in when we release air from a balloon. When we let the balloon that we have pinched off, when we release the pinch, the air will rush out downwards and the balloon will rush upwards due to the forces coming in pairs. Momentum is described in the last paragraph, and it's just mass times velocity. So, for example, a 300-pound football player running at 10 miles per hour has much more momentum and will cause much more damage when that person hits another person than will a 100-pound person running at 10 miles an hour. A larger mass has more momentum at a given velocity. Also, if a smaller object is moving at a very high rate, it has more momentum than the same object moving at a smaller velocity. That's it.